Hey, hey, okay, so all right, everyone, welcome back to CFD Simplified. Today's stream is going to be something really exciting because we are going to test a big question. Can AI actually predict CFD results? Usually, CFD simulations can take minutes, hours, or sometimes even days depending on the complexity. But what if we could train an AI model using CFD data and make predictions almost instantly? So in this live stream, we are going to build a complete AI-assisted CFD workflow from scratch using OpenFOAM and Python. We'll be using the famous hotRoom case from OpenFOAM, generating hundreds of CFD simulations automatically, converting those results into a machine learning dataset, and then training a neural network to learn the temperature distribution inside the room. And the best part is, after training, we'll compare the AI predictions directly against the CFD results to see how accurate the model actually becomes. This is not just theory, this is a real engineering workflow related to surrogate modeling and AI assisted simulations, which is becoming a huge topic in modern CFD and engineering research. So during this stream, we will cover automated dataset generation, Python scripting, OpenFOAM automation, AI model training, prediction workflows, and finally AI versus CFD comparison plots. Honestly, I'm super excited for this one because this could become one of the most interesting projects on the channel so far. So let's get started and see if AI can actually learn CFD physics. Okay, so give me 1 minute and I will be starting writing the code. Okay, just 1 minute. Okay, all right. So now we can start this simulation. Okay, so first, let us go to the uh, yes, go to this OpenFOAM tutorial. Okay, so all right. So first, let us go to Foam tutorials. Okay, so this will be find in heat transfer. Then we will have to go buoyant, Bosniak, simple foam, and here you will find the hotRoom case. Okay, so let us copy this case in a directory. Okay, in a directory named, what should we name it? What should we name it? cd make directory, make dir hot. Okay, let us make this. All right, so pwd, copy this, and we will paste it here. cp minus r hotRoom, paste. Okay, ls, yeah, it is all right. Okay, so it is done. Then we will clear this. Then what we will do? We will go inside the hot. We will go inside the hot room. Okay, then we will first copy this 0.org to 0. Then we will go inside 0 and we will check the temperature. Okay, all right. So it is fine. So first what we will do, we will run this one. Okay, we will run a single case. No, not constant. We will go inside system and then we will go inside control dict, and this one. So we will copy this. Okay, because it's a very big solver name. So we will go back. Let me clear the terminal. Then we will run block mesh. Mesh is made. Okay, then what we will do, we will run the case. Okay, press enter. So it will run for some time. Yes. Okay, it is done. All right, our case is done. So let us visualize our result in ParaView. ParaView.exe phone.foam. Okay, let us first see how is it looking, and then we will move on to writing the code of for generating the multiple cases and results. This is pressure, but we don't want pressure. We want our this room, basically room temperature. Okay, fine. Because the uniform temperature was 300, so that's why it is giving us 300 only. Okay, okay. Let us try to do that because I have not ran it previously. I'm going to run it with you only. Okay, we will run this case first time on live stream only. Okay, and we will just check how much result and what we will be getting from it. Okay, all right. So now let us go back and started writing the code. Okay, so we will make the file touch. What name should we give? Hmm? What name should we give? Let us say script.py. Okay, or let us say a cases.py. All right, it is made. So now we will go to gedit cases.py. All right, our gedit is here. Okay, then we will import some file. First import OS, then import shuttle, then import random, then import subprocess, then import numpy as np, then import pandas as pd. Okay, then we will write number of cases will be 500. Then we will make a template case is equal to os dot path dot expand user. Okay, here we will have to give the path. All right, so what we will do, we will open this, go to cd hot, then we will go to cd yes, hot room. All right, then we will write this pwd, copy this, and then we will again open our this, paste it here. Okay, and yeah, this is our path. Okay, then we will write output directory. Okay, output directory will be same. We will paste here, only we will change the name to generate or let us make the this directory. Okay, go back and make directory generated cases. Okay, go generated cases pwd, copy this. Okay, yes, all right, so it is also done. Okay, then we will write dataset file. This will be dataset dot csv. Okay, then we will write minimum temp is equal to 300. Then we will write maximum temp is equal to 400. Okay, then we will make os dot make the directories output directory exist. Okay, is equal to true. All right, then data set is equal to, okay, so this line will work for the storage part. All right, will work for the storage part. Okay, so now for case num in range num cases print f case num plus 1 divided by num cases. All right, then we will write random heater temperature. So heater temp will be equal to random dot uniform minimum temp comma maximum temp. Okay, Okay, then we will print one more message. Heater temperature is equal to heater temp dot to f. Okay, then we will create the case directory. So this is for create case directory. Okay, so case name will be equal to f case 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 num 04d. Okay, then case directory will be equal to os dot path dot join output directory case name. Okay, yes, this is done. Now it will remove if any of the previous case is will is there. Okay. Yes, if any of the previous cases there. So if os dot path dot exists case directory, then shuttle dot rm tree case directory. Okay, all right. Then copy the template case shuttle copy tree template case comma case directory. Okay, all right. Then we will write the code for modi to modify the temperature file. Okay, so that will be t file will be equal to t file will be equal to os dot path dot join case directory comma 0 comma t. Okay, then with open t file as f content is equal to f dot read. Okay, all right. So now we will replace the old temperature with the new one. So for that we will write old line. We will replace the whole line. Okay, basically if you can see here, this one, we go back, and if we go inside hotRoom, we go inside this and we will write nano t. So here you can see it is written uniform 300. We are going to change this one only. Okay, going to change this one only. So let us close it. Go back. Okay, old line is equal to uniform 300. Then new line is equal to f uniform heater temp to f content is equal to content dot replace old line comma new line. Okay, right. With open t file comma w as f dot write content. Okay, all right. So this will change the file. All file it will be changed. Okay, all the this temperature boundary condition will be changed. Okay, all right. So this is done. Now we will run the block mesh. Okay, now we will run the block mesh. Okay, all right. So run block mesh. Okay, so print, we will write a message running block mesh. Okay, sub process dot run block mesh. Right one, this log dot block mesh. Okay, then shell is equal to true, then cwd is equal to case directory. Okay, then run solver, print running buoyant boussinesq simple foam subprocess dot run. Again the same thing, only we have to, so let us 11, let us remove this, and what we can do, we can copy this and we can paste it here. We have to paste this one here. Here we can write solver. Okay, all right. Then we will find latest time directory, which is 1000 seconds. Okay, so time dirs is equal to this for item in os dot list directory case directory try time dirs dot append float item except pass. Okay, latest time is equal to str max time dirs. Okay, then we will print f latest time directory is equal to latest time. Okay, then we will read temperature field. Result file is equal to os.path.join case directory latest time with open result file r as f lines is equal to f dot read lines. Okay, then we will extract internal field values. Okay, so start idx stream is running, right? Yes, it is. Start idx num cells none for I line in enumerate lines if internal field in line and non uniform. Basically, we are now extracting the internal field values. So for that, we're writing the code. Okay, in line num cells is equal to int lines I plus 1 dot strip start idx is equal to I plus 3 break. Okay, if start idx is none then print error could not find internal field. Continue. temperature values is equal to this. For I in range num cells, value is equal to float lines start idx plus I dot strip. Temperature values dot append value. Okay, so this part is completed. Now we will create a data row. Okay, so we will create data row. Row is equal to heater temp plus temperature values. Data set dot append row. Print f saved len temperature values temperature values. Okay, all right, so this is also done. Now we will print saving dataset to CSV max columns is equal to max len row for row in data set. Columns is equal to heater temperature plus f this is basically we are saving our data set. Okay, so for I in range max cols -1. Okay, then we'll give some rows also if needed. So for a row in data set while len row is less than max cols row dot append np.nan. All right, so this is also done. Then we will define df is equal to pd dot data frame data set comma columns is equal to columns. Then we will save our CSV. Okay, so df dot to CSV data set file comma index is equal to false. Then we will print a message, print data set generation completed. Okay, and then print data set shape is equal to def dot shape. Okay, all right. So this is our code for the generation of the data set. All right. Oh my God, clear. Let us check whether we will get the data set or not. Okay, fingers crossed. Python 3 cases.py. I'm going to press enter. Ah, give error. Generated cases, case. No such file and directory, huh? Why is this there? Acha, this due to this decimal value it is not taking. Due to this decimal value it is not taking. Gedit edit cases.py. Oh. Mm, 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 mm. Let us remove this F because F is there for this. Save, clear, remove this. No, okay, generated cases. Remove this case. Okay. Okay, let us try once again Python 3 cases.py. Okay, okay. Mm, 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 mm. First, we will go here and remove this -r. Okay, then we will go back. Clear. We will write again. Go to gedit cases.py. But why it is not? Mm, 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 mm. Mm, 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 mm. We have written the whole code correctly. Okay, only these small things, and that is which makes irritating. Okay, and that is why we have done 99% of the things right. This 1% is just like, and this is very frustrating. अरे यार फिर से नहीं ले रहा ये. Mm, 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 mm. Mm, 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 mm. This one is the same or not? Let me check. cd user, cd lib, cd OpenFOAM. No, it's not there, right? OpenFOAM. Where we are? Uh, OpenFOAM. OpenFOAM 2412. Then OpenFOAM etc. Bash or is there? Okay, fine. But basically, I just wanted to know about this part. User lib OpenFOAM 2412 etc. Okay. Same here. Bash minus C. Then again this source and then this source user okay. All right. Another part is I have removed this. कितने अरमान मान मान जाके दरवाज़े सोनिया ओ कितने अरमान मान 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 जाके दरवाज़े सोनिया all day all night मुझे याद सताए तेरी याद सताए याद सताए Okay, let us run it again. Python 3 cases.py. Block mesh is running fine. First of all, this heater temperature also, right? Our code is fine, man. It is fine. Why it is giving like this? Why it is behaving like this? ठीक है, ठीक है, ठीक है, ठीक है. अभी this was buoyant Boussinesq simple form. Oh, what is wrong in this? Oh, SQ. Let us now try to run this. Okay, so above problem is solved. Now this part is remaining. Let us see. We can solve this part also. CD cases, oh no. gedit cases.py. First and foremost, uh, 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 mhm, mhm, mhm. This latest time it is for this int save cancel save clear generated cases. Okay, Python 3 cases.py. That's just writing 500 cases. This is the power of automation, man. Sit and enjoy. Mm. Okay. Hello, Jay. I am good. How are you? You are still awake? See, today I am showing the power of artificial intelligence in CFD. Automatic writing the cases. Make one automated code of Python and then automatically it is running and writing the results. Let's see whether it will save. Alex, I don't know what you're saying. Let me use this Google Translate. This camera. Food poisoning. अरे Oh, yeah. Okay. Thank you, Alex. Let me please see language. How are you right now, Jay? If Alex, you are here, Gemini has given this value amigo tamajunto for Alex. Value amigo amigo tamajunto. Little bit better. What about the medicine? Huh? The PINs in aerofoil, yeah, that can be used, but that will be very heavy actually. Why you have deleted the message? I have kept that in my mind. I will try to use it, but I know that will be very heavy and very complex thing. Yeah. Yes, it is. But currently, right now, I'm not using PIN and in today's live stream. Uh, for the aerodynamics, it is basically the normal neural networks that is being used. Our sir is very expert in that. He used to do he does this thing only. First run CFD. अरे कोई बात नहीं भाई यार दोस्त लोग हो तुम लोग ध्यान रख भाई जय अपना यार पीएचसी गए थे बड़े ओके सो no so you have gone to PHC or not? No, but why? You should have taken the medicine now. Okay, so our data set is ready. Let us open it and see what it has written. Okay, all right. So now जाना चाहिए था यार। क्या खा लिया था तू? बाहर का खाता भी नहीं है तो मेस का ही खाना खाता है। हाँ, तो गर्मी बहुत पड़ रही है, कुछ बाहर रखे होंगे मेस वाले, उनसे ही हो गया होगा तुमको भी। ध्यान रख भाई यार, उनको तो टेंशन हो गई। Okay, so now we will write the code for training. Okay, so first write down touch train.py, and then gedit train.py. अरे यार, just not opening. Okay, no issues. We will open it in notepad.exe train.py. Okay, now let us not do that. Let us see if we can open visual code.exe train.py. Visual.exe train.py. अरे nano uh, train.py. Okay, now let us start. Import and as pd import. अच्छा, okay, but have you seen my yesterday live stream? Go to the end and see the plot. Jay, what it has generated only by AI. Okay, please go and see the plots. I was very happy. Import matplotlib dot pyplot as plt, and from sklearn dot model selection import train test split from scikit-learn dot pre-processing import min max scaler, then import tensorflow as tf from tensorflow dot keras dot models import. First, don't go into learning this Python and all those things. Okay, take a problem and start applying on it. This PINNs, okay, small problem like the way I am doing. Like first I have done a very small problem, then second I have gone to this, third my plan was to go to Navier Stokes, but I was thinking of, I thought that okay, first let us go on that because this was, looking for me, it is like very, I want to work on this right now. That's why I started doing live stream of this. Next I will try to do the live stream of that Navier Stokes solving using PINNs only. Okay, so gradually you can im- uh, you know increase your this way, but first you need to understand your this some coding of pin which is there in between. Okay, don't go for the syntax part because basically what people do in these days, they started learning the syntaxes of the Python. No, don't, that is not required. The main structure you need to understand, and then after that it will take it. Okay. So from TensorFlow dot keras dot callbacks import early stopping. Okay, then we will load dataset. Okay, so print loading dataset. Okay, dataset file is equal to dataset dot csv. Now read csv. Df is equal to pd dot read csv dataset file. Print df dot shape. Print df dot head. Ulrich Binash, thanks for your work. It is help a lot. Okay, you're welcome. You're welcome. Then we will write down the x. Okay, so x it is heater, temperature, values. Y is equal to df dot drop columns heater, temperature, values. Okay, then print input shape x dot shape. Print output shape y dot shape. Okay, so this is the input output. From here it is input output. Okay, let me, that's why I wanted to write it down in gedit, but I don't know why it is not writing today. Outputs. Okay, then we will come back and write normalize data. Okay, let me present it. True. Print normalizing data. Could you please maybe later do a video about GNN, which is more useful today in OpenFOAM? GNN. Okay, 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 okay. Let me write down. Let me write it down. GNN. 'Cause next live GNN in OpenFOAM. Okay. If the code will get prepared and I will be confident and I will come back and we'll we'll do a live stream on that. Okay. Where are you from? Ulrich Benash 2338. X scalar is equal to min max scalar, then y scalar min max scalar. Okay, then x scaled is equal to x x scalar dot fit transform x, and similarly same thing, copy paste, only we will change it to y, change it to y, change it to y. Then we will train test split. Okay, train test split. So x train comma x test comma y train. Okay. I will I will definitely try to make a video. I cannot promise because sometimes it becomes more complex, but yeah, I will try to make the code live stream on that. Okay, if the code will be ready, then I will try to make it. Okay, because people have requested me regarding, okay, can you please make the video on this, can you please make the video on this, because just like they wanted to try to solve their whole projects, research projects. Okay, I said, okay, I will try from my side, but I've already tried, but what has happened in that is like I was not able to make videos for like 1 week and 2 weeks. And about the complexity of OpenFOAM, like solving a new problem, it is like very complex. Okay, but so then I decided, okay, let's, so then earlier I have made promises, but now I don't make any type of promise. So that's why I'm telling you that, okay, I will try from my side. Okay. So I'm confident I will be able to run their problems also, but it is stuck in my video and I wanted to upload it daily. Okay. So that was the thing. Yeah, I will definitely try, and if it is, if it will be ready, then I will try to I will do a live stream, and then you can see how it is going to happen. Oh no, true. X train, Y train, train, test, split, X scaled, Y scaled, test size 0.2, random Random state 42. Okay, then we will again print. Yeah, yeah. Okay, fine. I was just telling you my experience. Okay, one guy, he has emailed me. He was doing some project. I said, okay. Uh, he was, you know, he started behaving like that, like I should do his all work. He just write the email. He sent me single email, and single email is just written that. First, he was asking about the path of the tutorial which I have taken. I said, all the things are given in the video. Just go and watch it. And these tutorials are there in OpenFOAM tutorials. You just go to this path, and you will find it. Then he again mailed, no, can you please make all the things of whole video on this problem? That was his uh, master's project topic, and he wanted me to solve it. I said, "You are just man. Like I can help you if you get into stuck in between. Then I can help you. But running your whole is like new researches are using OpenFOAM. It is like I don't have that much time to do that. I want to. I can help him. That is not an issue. I must have helped him, but I don't have that much of time. Okay, because so due to time restraint, I said, brother, please. Thank you very much. Thank you very much. You made my night. Thank you. Thank you for that comment. Thank you. Crazy. I helped, but people are very good also. First email I received, that was two girls from Morocco. I don't remember their name. I forgot. So, but they were on my WhatsApp also. But I don't know right now they watch my videos or not. So they were also doing this BTech. So I some projects they were doing with the help of OpenFOAM. I was not able to help them in the full project, but I helped them in middle part. Okay, because they were not able to run the simulation in the starting only. Okay, Jay, they have given my name in their thesis which they have represented in their presentation in their college. Their presentation was there, and there they have represented it like this man is there, he helped me, as they have put my name in that. So there are very lovely people also, but yeah, there are like these people also, so mix of them. Yeah. I don't I forgot their name, and it was just like oh, this like 1 year is happening. Building. Where we were? Building. Yeah. Okay. So we are building neural network. So model is equal to sequential dense activation. Like you also. I'm just thinking like how I have helped Mr. J, but you have mentioned me also in your that project report of yours. Hard work is the key. Now I ran my simulation. I have my data set. So I was just thinking on how to practice, and you came and saved my life. Arey bhai, you are Indian, Ulrich? You are Indian? Or what is your nationality? Ulrich, please try to, share this video with your. Okay, you're from Cameroon. Okay, all right. All right. Please try to share my channel to your other friends also if they can also need, uh, you know, watch it, and if they can subscribe also, it will be very beneficial for me. Okay, so now we will compile our model.compile optimizer is equal to idem loss is equal to msc matrix is equal to MAE. Okay, so model dot summary. Okay, we will put on one uh, early stopping, early stop is equal to early stopping monitor is equal to loss patience is equal to 20. Okay, so Ulrich, do you have in your college like those all these okay, it's Canada, I think it must be there, all the resources to run some simulations or something like that, like HPC and other things. It must be there, but yeah, I'm just asking because those the girls which I'm talking, I was telling you all, those are from Morocco, and there they were not having any type of things, and they were running CFD in their laptop with a 16 GB or 8 GB RAM was there. And I was like, man, how you're going to run it? Your presentation is there after 2 3 days, and how you're going to run it? I mean, uh, but they just, I don't know how they managed. I forgot their whole story. But yeah, because resource if you don't have, then it will be very, very, very big hurdle. Yeah. Okay, fine, brother. Fine, fine. Okay, that's good to hear. History is equal to model fit. If you get the slots in HPC, HPC is a life savior. Jay, are you here? Remember our HPC struggles. Validation plate 0.2. Epochs is equal to 500. My live stream is coming, right? Yes. Batch size is equal to 16. Callbacks is equal to early stop. Verbose is equal to 1. Okay. Now we will evaluate model. Print evaluating uh, what is the meaning of evaluating model loss MAE is equal to model dot evaluate test y test print old age. What is the meaning of patience is equal to 20? Patience is equal to 20 is basically it will test for basically training will stop if the validation loss does not improve for 20 consecutive epochs. Okay, so it will check for validation losses. Okay, but if another for 20 epochs it does not improve, so it will stop, training will stop. Okay. So basically it is for to save time. Okay. Stop wastage of time, unnecessarily training, to stop that. Okay. I think today we will be able to make the training model only. Tomorrow we will be able to compare because I have to go to sleep also. And otherwise, tomorrow's gym session of mine will be gone. And I don't want to do that. Save hotRoom AI model .h5 print model saved successfully. Okay, now we will plot training history. Why they are not adding this even when I was. Yes, sir, I am. Those days are so hectic. That's why whole project was shifted from main things to small part. It is must to have a machine generation availability, but it's not. I don't know why they're not adding this. Even when I was asking doing freelance and you says SPC is it was you can do anything. Acha, so they are not allowing to do so meshing basically. I don't यार जानते हो यार तुम उनके रेस्ट्रिक्शंस तुमको पता ही है नए नए तो रेस्ट्रिक्शंस लगाते रहते हैं वो एक तो किसी को वहां पे एनसिस लिंक करना नहीं आता है एचपीसी से मेरा केस में समझ रहे हो ना मेरे केस में क्या था भाई पैराव्यू था तो पैराव्यू डायरेक्टली मैं चला ही नहीं पाता था पहले डाउनलोड करो तब चलाओ पैराव्यू तो डायरेक्टली एचपीसी से लिंक हो जाता है वो कर ही नहीं पा रहे थे वो लोग मैंने खुद ट्राई किया तो फिर मैंने कहा भाई छोड़ो बैन वैन कर देगा एक ईमेल आ चुका है मेरा तो धंधा बैठ जाएगा मैंने कहा, छोड़ो मैं अब डाउनलोड करके ही करूंगा फिर और क्या करूंगा हाँ वो जय महाकाल पता नहीं है कि चलेगा स्टाफ चेंज हुआ है कि कॉन्ट्रैक्चुअल थे कि परमानेंट थे वो I don't know। जय देख मैंने रिमोट रिमोट वाला सीलिंग फैन लगाया है बैठे बैठे रिमोट से ऑन कर लो अभी लाइट चली गई तो सीलिंग फैन ऑन कर लिया पांडे ही था बियर्ड बियर्ड वन गए तो थे यार अपन मिलने के लिए याद है इतना इतना बड़ा सा है छोटा सा plt डॉट एक्स लेबल epoch plt डॉट y लेबल loss plt dot title AI training history. अच्छा अच्छा अच्छा। उसको सिर्फ लाइनेक्स पे काम करना आता है। उससे कोई सॉफ्टवेयर लिंक करने को बोल दो ना, उसकी हालत खराब हो जाती है, उससे होता नहीं है। Okay, so we have reached up till here. Now we will test a new temperature. So, example, heater temperature. So, new temp is equal to np dot array 350 normalize input even सही में है। 1 minute, Ulrich, 1 minute. We complete this temp scale transform भाई ऐसा किस काम का भाई फिर है। मॉडल डॉट प्रेडिक्ट न्यू टेम्प scaled convert back to original scale prediction is equal to y scalar dot inverse transform prediction scaled print prediction shape prediction dot shape. Okay, now save. So for saving predicted field is equal to prediction dot flatten np dot save predicted predicted temperature field dot npy predicted field print prediction saved successfully. Control O, save, Control X. Python 3 train.py. Scikit-learn is not there. अरे यार pip install तो मैं नाम भूल जाता हूँ यार उसके अरे भाई लास्ट में कमेंट क्या था उसका Ulrich, why when people use CNN or GNN they don't include the psych in the model? You wanted to ask when people use CNN or GNN they don't include the I don't understand your question Ulrich. भाई जय यार epic people. I so this is whose fault is this? Whose fault is this? Then it is the fault from ANSYS. They must have given some type of solution. अरे नाम ले लिया यार नाम नहीं लेना था नो फ्री एडवर्टीजमेंट इज रनिंग 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 वही तो बात है यार उनसे ज्यादा तो हम लोग को आता है वो भाई मैं अपना सेट फोन करवाने गया था वो अरे यार इतना चलने के बाद भी फिर इवैल्यूएट था। हाँ। In the current one, I'm not using this one because this is used, if I'm not wrong, psychic is used in physics is used in this one, PINL. Okay. So this one, it is normally we are using MSc, not this. I'll send you one channel link and please check the things he is doing is also next level. Okay, okay जय, भेजिए भाई देखेंगे। नहीं तो जय आंसर माय क्वेश्चन, whose fault is this? Now in this case I will take the side of IIT Jodhpur only. Okay, because now it is not their fault. It is the fault from NCS why they have given this bug thing. And the thing is, people think of becoming so much expert because they are using on their own systems. Model is saved successfully. Where is the plot? अरे यार ये अच्छी बात हो रही है। Why it is not? Let me open it again यार। ये नहीं खुल रहा था। Okay, we cannot see the plot as it is. It was this, you know, that uh, window was not opening. All right, no issues. We will see it next time. Arey, not this is not the fault of GPT. I mean, I was just having this thing like in our campus, every professor have their own systems in their lab, so they try to run there. In our case, I think we are the only people who are doing the things on main HPC. Okay, and by linking the software and all those things, and that is why now these things is occurring because this thing must be there from long time. Okay. All right. So we will stop here only. Okay. Because it's very late at night, and then tomorrow in the live stream we will this training we have done. Then in the next code we will this compare the or temperature plot of the predicted by the AI and from the CFD data which we have got temperature. Okay, so that we will write the code and try to make a prediction of that, try to make a plot of that, so that we will get a very good idea, like whether with what we wanted to do, whether it was successful or not. Okay, till now all the steps which was required we have done it, and we were successful. We have ran 500 simulations very smoothly by writing a code, a long code. It has automated our things, and it has automatically changed our temperature values, and it has written the code automatically. Okay. uh, then what we have done. Okay, so 500 simulations we have. Then we have in that code only we have written the whole data set of created the whole data set of 500 different cases. Okay, that we have written. Then we used that data set to train our model. So model training is done. Up till model training we have completed. Now the thing is that we have to compare the results. Okay, the AI generated and the actual CFD results which is there. Okay, then we will get a very good idea that whether what we wanted to show, what I wanted to show, that whether AI is being successful or not. It is successful. Research papers are there, they have shown. But yeah, from live practical example, I just wanted to show from my side also. All right. So good night. We will. Can we get that code? You want code? Okay. I will post it. All right. I will make a post in this on YouTube and try to provide one link, so you can go and download it from there. Okay. Or if you wanted to see, like, then you have to see that whole code writing. I know that will be very like slow thing it will be, but don't worry. I will try to post a link on YouTube post. Okay, if it is successful, then you can go and have the code from there. All right. Okay. So good night, everyone. I will meet you tomorrow. Thank you for watching, and I love you all. Be happy, earn lots of money, go and buy whatever you wanted to buy, enjoy your life, and be happy. Okay. All right. Chalo. Bye. Take care. Good night. Love you all.